Hello everyone. We are a group of engineers from the Kate Gleason College of Engineering at RIT. And our team is the ConcRIT 4.0, which is a small-scale 3D printer for concrete. Concrete printing is currently in use today with large-scale projects such as printing wind turbine towers and structures for sustainable housing. In our case, the goal of the ConcRIT 4.0 is to create concrete prototype parts for RIT students, faculty, and research partners, which will help to reduce the costly process of using wooden molds.
Last year's team utilized a design that required concrete to be pre-mixed by hand and then added to the hopper. The cone-shaped hopper had an auger that was used to force the pre-mixed concrete all the way to the print head. This design led to the team dealing with clogged tubes and inconsistent flow of concrete. The main goal for the team and the client is to produce a functional printer that can take concrete mix, whether it's pre-mixed or mixed in real time, and deliver it to the print bed consistently. The team is operating under specific engineering requirements, such as being able to print 2 full bags of concrete, staying within the original printer's footprint, and being able to consistently deliver a bead of concrete to the print bed.
When facing complex engineering challenges, such as our senior design project, groups typically run into a sticky detail at one point or another in the process. This could be an interesting challenge that was faced, a difficult decision that was made, or even a significant risk that the group took. In our case, we ran into not 1, but 3 sticky details where we took significant risks in our process. Whether it be accepting the challenge to create a real-time mixing system when it was just an idea, putting all our chips on our custom-made flight auger to mix concrete effectively, or even hoping that our inline vacuum system would be able to transport the dry concrete mix without clogging or turning the lab space into the dust bowl. We essentially took a leap of faith with each of these decisions and have been met with quite a bit of relief to know that these were not grave mistakes, but monumental successes in our project.
The dry material is loaded into a sheet metal hopper that can hold up to 2 bags of concrete material. Gravity then works side by side with the vacuum pump that is connected to the bottom of the hopper in order to move the material through the hose to the mixing station. For the water transfer system, a 5-gallon holding tank is utilized, which is connected to a 12-volt water pump using 3/8 vinyl hose. Additionally, a needle valve is used to control the flow of water that enters the flight auger, where it will then be mixed with the concrete powder. The mixing system consists of a horizontal stainless steel pipe that houses a flight auger, which is hollow in the center. The dry material and water enter at the far end of the mixing pipe, and the flight auger mixes the correct combination of powder and water as it travels toward the extrusion auger. This allows for fully autonomous, real-time mixing without any manual labor.
The extrusion system consists of a DC motor along with a 3D printed auger and nozzle contained within the 3¼ inch stainless steel pipe. After the concrete has passed through the mixing assembly of the pipe, the mix is channeled down the pipe using the auger, which will assist in compressing the material prior to reaching the nozzle. The nozzle allows an extrusion of concrete with a bead size of 1 inch. The print head and attached components are moved utilizing a Cartesian gantry system. Both the Z and Y axis each utilize 2 stepper motors. The Y axis moves the print bed itself back and forth. The Z axis raises the print head, mixing assembly, and X axis frame. Lastly, the X axis has 1 stepper motor allocated to traverse the axis.
We would now like to thank our client, Dr. Sarah Brownell, for all her support and faith on this project and on the team. Our guide, Oliver Miller, for his guidance and support through every phase of the project. Our SME, Dr. Dennis Cormier, for meeting with us multiple times, helping us in whatever thing we needed, and sharing his knowledge on 3D printers with us. Rob Kraynick and the shop guys for always being super willing to help with anything we needed in the shop while building our 3D printer. SMC Metals for providing us with the sheet metal we used for the hopper, and anyone else who was always willing to give us advice and supplies for our project.